All right, so this is our second podcast of Unit 1, and we are going to be covering most of page 3, but not quite all of it. You do not need to finish page 3 completely to get your stamp next class, just this top section of it. We'll fill in the bottom in the next podcast. So, right at the top of the page, what we're going to be talking about is the scientific method. And you've probably heard of this before, hopefully. And it's just an organized process used by scientists to do research. And the key word there is organized. It's a very specific process, and some people have slightly different steps, but it's always kind of a circular process where you have a question and you go through specific steps in order to best answer the question and know for sure that you got the answer that you're looking for. And it's called the scientific method because all sciences use it. We're going to use it here in chemistry, but they also use it when doing biology or physics research and other science, technology, engineering, and math research. Anything where you have to try and answer a question and you want to have a reliable result, you can't just kind of do stuff willy-nilly. You have to go through an organized process. So that's our scientific method. Now, we have a couple of words right underneath scientific method that we've already defined for you. These are just some words that I want to make sure you understand the difference between. And they're all very similar, and sometimes they're used interchangeably. But a hypothesis, which we might write before our lab next time, is a temporary explanation. And generally, it's a starting point for further testing. So you might say that you expect increasing the water that you give a plant will increase the size of a plant. That's an explanation for what's going to happen to the plant if we add more water. But there's only one way to tell if it actually is true, and that's to test it. After something's been tested and well substantiated enough, and enough people have agreed that that is probably true, then we call it a theory. And you might think, well, wouldn't that be a law? But it doesn't necessarily rise to the level of being a law until it's universally accepted. Everybody agrees that that is true and that relationship is something that we can count on. So even gravity technically is a theory. It is very well tested, and we know if we hold something out and let go of it, it will drop down because of gravity. But there are some kind of bits and pieces, and really it's the source. Where does that gravity come from? And kind of a little bit of how it works that we haven't gotten to that universally accepted level of yet. So in this class, because it is just high school chemistry, we're mostly going to be living in this hypothesis world. We're going to try and make some assumptions and explanations and then test them, but we're never going to quite get to theories and laws, at least with the level of experimentation we're doing. Now, there are two different types of data that we can collect in the process of doing an experiment. We've got qualitative data and quantitative data, and these are very similar words, but if you focus on their root word, qualities for qualitative and quantities for quantitative, that can generally help people tell the difference between them. Qualities are generally words describing something, especially the physical characteristics of substances here in chemistry. Something like the color, it's blue, or it stinks, or it's a triangle. Those are all words describing our objects. Quantities and quantitative data is always going to come back to numbers, or quantifying the amount of something, how much or how little you've got. So saying not just I have a little bit of a chemical, you could say I have 5 grams, or I have a lot of dogs would be qualitative, but if we want to make that quantitative, I could say I have 8 dogs. In my dreams. Maybe one day. Now, there's also a couple different types of variables, and we are going to talk about these in our lab and more in class, and people tend to confuse these a little bit. So let's go ahead and get our definitions down. Independent variables don't depend on the other variables. Just like if you're an independent student, you don't depend on someone else to get your work done. This independent variable does not depend on other variables. It's generally the cause of whatever change you might see in your experiment. Dependent, on the other hand, as the word implies, depends on changes in the independent variable to cause that dependent variable to change. So it does still change. It is a variable, but it's generally the effect of the change, not the cause. So with that experiment I was kind of talking about earlier, if I give a plant more water, I think that it will grow taller. The independent variable is the amount of water I'm giving it, and the dependent variable, the thing that will change once I give it more or less water, is the height that that plant will grow. Now, in any kind of experiment, we are going to have a control, which is a standard used for comparison in an experiment. If I was talking about giving more water to a plant to see if it grows taller, if I just grew one plant and put twice as much water in it than I did for other plants before, then I wouldn't really know if that plant grew taller because of the water or because of some other factor. Maybe it's in a different place than the other plants. Maybe it's a different type of plant than the other plants I've grown before. So for the best experiment, we would need to have one plant of the same type, as everything is the same as possible as the plant we're going to change the amount of water on, so that the only thing different between the original plant and the other plant is the amount of water, and then we can compare it better and see if the water is the thing making it grow taller, or if maybe there's some other factors there. Sometimes that control is called a baseline. It's an experiment where you'd kind of just do it normal. It's kind of the most boring part of the experiment, but that's the important part for comparing it to the other changes and seeing those effects and relating everything together. And of course, an experiment, we've been talking about that and I've been throwing that word out there, but keep in mind that an experiment, just like our scientific method, is all about careful changes and observations, and it's designed to test a hypothesis in order to evaluate if that hypothesis is true or not, or if we need to adjust it. So I had my little pictures here, my plant with less water and more water. I don't think the pictures were as helpful as we needed. So last two little things. What's the function of a control in an experiment? Well, as I was just saying, it's used to compare how changes that we make affect that experiment. And now it asks for you to give 2 examples each of our qualitative and quantitative data that you collected from your bedroom. And I need you to do that. So I don't care how you organize it. If you want to do just kind of 2 lists, have qualitative written one place, quantitative another, then make sure you at least find 2 things. Just look around the room you're in, even if you're not in your bedroom. I don't care whether it's in your kitchen or your living room. Make sure you have 2 things for each of them. If you don't really feel like you have enough vertical space there before the word chemistry starts, you can feel free to do that across. Instead of vertically, just write the words qualitative, quantitative. I don't just want 4 random facts. I want to see that you got them in the right place in order to get you your stamp. So we'll see that, talk about it next class. Hopefully this wasn't too bad.